Good morning. Today we're going to talk about solving radical equations. It's section 5.4 in our book. I'd like you to take a minute and put these in your notes while we talk about them. The first thing that we're going to do is we're going to isolate, which means to get the radical by itself. Then we're going to think about whatever radical we've got, and we're going to undo it by doing its inverse. So if it's a square root, we're going to square things. If it's a cube root, we're going to cube things. And so that's what this is saying. Raise each side of the equation to the same exponent to eliminate the radical. So that's our goal here, is eliminate the radical. And then finally, we're going to solve just like we've solved in the past. Okay, so let's look at the next example. First of all, let's take a look at letter A. What do we have to do to solve this one? Is the radical by itself? No, it's not. If you need to, circle the radical so that you can see this is the only thing under the radical, and then take care of what's outside the radical. What's outside the radical? The plus 1 or the minus 1. How am I going to move it to the other side? I'm going to add 1 to both sides. Okay. When I do that, I get the square root of x minus 1 equals 1. Now what I need to think about is what's going on over here. I'm taking the square root. Well, how do we undo the square root? Right, we have to square it. But if I square this side, I have to do the same thing on this side. When I square the square root, remember this could be written as x minus 1 to the 1/2 power. That's what it means to take the square root of something. And then if I square that, this gives me an exponent of 1, which just leaves me with x minus 1. And 1 squared is 1. Now I can solve. This just takes me back to algebra 1. I add 1 to both sides. And I get x equals 2. I should always go back and look. If I put a 2 in here, does that actually give me a positive 1 and then 1 minus 1 is 0? Yes, it does. So will you take a look at this one? It's similar. What do you think you have to do with it? All right, so what would you do first? You would add x to both sides. So you get that the square root of x plus 2 equals x. Now, how do I undo the square root? By squaring it. But if I square the left side, I have to square the right side. So it's similar to this one, but there's a little bit of something we have to think about when we do this, solving this one. Squaring the square root undoes this, so I just have x plus 2. But on this side, I have equals x squared. It's not like this one over here. I can't just subtract 2 from both sides. What am I going to have to do to solve a quadratic? That takes us back to things we did before. So we're going to need to set it equal to 0. Remember, I always like my x squared to be positive. So I'm going to move these things to the other side. Notice I'm not lining that x up underneath that x squared because I can't subtract those two. So this leaves me on 0 on this side. and leaves me with x squared minus x minus 2 on this side. Now we get to do my favorite thing. We get to factor, so we need to think about what multiplies to give me negative 2, and adds to give me negative 1. That's going to be a negative 2 and a positive 1. And so this is going to factor into x minus 2 and x plus 1. Equals 0. Now what do I have to do with each of those? I set them each equal to 0. And I solve. So here x equals 2. And here x equals a negative 1. Now again, remember I said we need to check. If I put a 2 in here, I get 2 plus 2, that's 4. 4 minus 2, or excuse me, the square root of 4, minus 2 does equal 0 because the square root of 4 is 2. But if I put a negative 1 in here, I get that the square root of 1 minus a negative 1 equals 0. Well, when we're solving, we are only looking at the positive square roots. Square root of 1 is 1, but minus a negative is plus. So is that a true solution? No, it's not. So this is my only solution for this one. So remember, it's always important that we check to make sure that our answer does not give us a negative value. And so we can't say that the square root of square root of 1 is negative 1, and so this does not work. Now let's look at an example of something that doesn't have a squared term in it. We're going to do letter B over here. Okay. First of all, ask yourself, is the radical by itself? No, it's not. Again, if you need to circle the radical, then circle the radical. Is there anything outside? Yes, there's this 1. So I need to move it to the other side. When I do that, these are going to cancel. I'm going to be given a 3 over here. And I have the cube root of 2x minus 9. Now I'm taking the cube root here. But I have to undo the cube root. What would I have to do to undo the cube root? Right. I would have to cube both sides. Whatever root you're taking, you're going to use that exact same root as your power. So cube root, cube both sides. Fourth root, fourth power. Fifth root, fifth power, and so on. These undo each other, so I'm left with 2x minus 9. But 3 cubed is 27. I'm going to add 9 to both sides. This is going to simplify, cancel out, leaving me with 2x on this side. 27 plus 9 is 36. Divide both sides by 2. And I get x equals 18. Okay, again, go back and check. Try that 18. If I put 2 times 18, that gives me 36. 36 minus 9 is 27. What's the cube root of 27? Positive 3. Minus 1 gives me a positive 2, so that one works. We can also look at these with fractional exponents. It's the same concept, we just have to be a little careful here. Again, is this fractional exponent by itself? No, it's not, so I need to subtract 2 from both sides. When I get that, I get 2x to the 3/4 power is equal to 8. Okay? Well, now I need to think about what this is saying. Remember, this is the 4th root, and this is the 3rd power. Well, how would I undo the 4th root? I would take it to the 4th power. How would I undo cubing something? I would take the cube root of it. So in other words, I would take it to the 4th power and then take the cube root of it. What I end up using is the reciprocal here, because if I take 3/4 times 4/3, that becomes 12 over 12, which is 1. Have to do the exact same thing over here, though. These are going to cancel, leaving me with 2x. And this is 8 to the 4/3 power. Okay. Now I need to think about what this means. I don't want to divide the 2 yet until I get this simplified, because this 2 and this 8 are not the same base, so I can't do anything with that yet. Okay. Well, this says to the 4th power of the cube root, so I could write the cube root of 8 to the 4th power. But I should know what the cube root of 8 is. The cube root of 8 is 2. So I have 2 to the 4th power. Over here I have 2x. But I can actually calculate what 2 to the 4th power is. 2 to the 4th power is 16. And I have 2x equals 16. Divide both sides by 2. And I get x equals 8. If you didn't remember how to do this, remember the other way to do this would be to put this in your calculator. This is saying the same thing as 8 with a caret of 4 divided by 3. Make sure when you do that you put parentheses around this. Either way, you should get 16 here, and then divide by 2, and you end up with 8. Now let's go back and check. 2 times 8 is 16. 16 to the 3/4 power. Check it out on your calculator, but you should get 8. 8 plus 2 is 10. Okay, now we're going to take a look at this one. This one happens to have 2 radicals, so I can't really isolate them, but I do not want them on the same side. I want each one on the other, on separate sides. So I'm just going to choose to add this one to both sides. Okay, so when I move this x plus 4, square root of x plus 4, excuse me, to the other side, they're going to cancel here. Now I have a radical on either side. That works out kind of nicely, because then, how would I undo this radical? I'm going to square it. But if I square one side, I have to square the other side. And look what happens. When I square this side, the radical goes away, so I'm left with 2x plus 2. And when I square this side, its radical also goes away, so I'm left with x plus 4. That's an algebra problem that I can solve. I'm going to subtract x on this side. And I'm going to subtract 2 from this side. The x's are going to cancel here. The positive 2 and negative 2 is going to cancel here. 2x minus x is x. 4 minus 2 is 2. Now I do need to go back to the original problem and double check. 2 times 2 is 2 plus 2. So let's put this in. 2 times 2 plus 2 is 4 plus 2, which is the square root of 6. Does that equal, we're asking ourselves this question, the square root of 2 plus 4? Well, 2 plus 4 is 6, so yes, the square root of 6 equals the square root of 6. All right, now we're going to look at the next type of problem. This one. Again, we need to ask ourselves, is the radical by itself? In this case, no, it's not, because this minus 1 is outside of the radical. So I need to move this to the other side. I do that by adding 1 to both sides. So I get x plus 1 equals the square root of 7x plus 15. Now, in order to undo this radical, I have to square this side. But if I square this side, I have to square this side. We need to think about, what does x plus 1 squared mean? Right, it means to multiply x plus 1 by itself. I cannot just square the individual pieces. I have to take x plus 1 times x plus 1, and I have to either do the distributive property or that shortcut we call FOIL. Squaring this side does get rid of that radical. So pause it a minute here so you can try this, multiplying this out, and see what you get. Okay, check your work. Did you get to here? Now, again, we have to think about the fact that I've got a squared term, so I can't just do my algebra. This x squared is here. If I had the 2x plus 1 and the 7x plus 15, then I could just do some simplification. But because I don't, I have to set it equal to 0, which means I have to subtract 7x here, and I have to subtract 15. This is 0 over here. When I combine like terms here, I get x squared minus 5x minus 14 equals 0. So guess what? We get to factor. So let's think about what factors, what multiplies to give us negative 14 and adds to give us negative 5. How about negative 7 and positive 2? So this is going to give me x minus 7 and x plus 2 equals 0. Once we have it factored, what do we do with each part? Right, we set it equal to 0. So here we get x equals 7. And here we get x equals negative 2. Now again, we have to remember we need to go back and check. So we need to go back up to this original equation and see what we get. Okay? If I plug a 7 in, I get 7 equals the square root of 7x plus 15, So 7 times 7 plus 15 minus 1. 7 times 7 is 49. 49 plus 15 is 64. The square root of 64 is 8. And 8 minus 1 does equal 7. So 7 is an acceptable answer. If we do the negative 2, I get negative 2 equals the square root of 7 times negative 2 minus 50, or excuse me, plus 15 minus 1. Okay, that's a negative 2 there. So that should be a 7 times a negative 2 there. Well, 7 times negative 2 is negative 14. Negative 14 plus 15 is 1. The square root of 1 is 1. Is 1 minus 1 equal to negative 2? No, so this one does not work. This is the only one that works. You have to make sure that you practice and that you go back and check every single answer to make sure that what you get is the correct one. These are called extraneous solutions, or solutions that don't work, and we need to make sure that we have those. All right, I'd like you to try this example on your own. Okay, so now that you've had a chance to look at it, let's talk through this together. We have to square both sides. This radical is already by itself, so that's okay. So I square both sides. When I do that, I need to remember that x minus 4 squared is x minus 4 times x minus 4. When I square the square root goes away, and so I have 2x plus 7. If I multiply out x minus 4 times x minus 4, I get x squared. I get minus 4x, and another minus 4x, and a negative 4 times a negative 4 gives me plus 16, and then I'm just left with 2x plus 7 over here. Now I've got this squared term. I'm going to go ahead and combine up my like terms. Which gives me x squared minus 8x plus 16 equals 2x plus 7, and now I want to set it equal to 0. When I set that equal to 0, I get x squared minus 10x plus 9, so I need to ask myself, what multiplies to give me 9 and adds to give me negative 10? Well, negative 9 and negative 1. So that's going to factor into this. Then I have to take each part and set it equal to 0. X minus 9 equals 0 and x minus 1 equals 0. If I set x minus 9 equal to 0, I get x equals 9. If I set x minus 1 equal to 0, I get x equals 1. But I'm not done because I have to remember to check. When I check this, what I see is plugging in a 9 for x into this original equation up here. I get 9 minus 4 equals the square root of 2 times 9 plus 7. Well, 9 minus 4 is 5. 2 times 9 is 18. 18 plus 7 is 25. The square root of 25 is 5, so that works. Here, when I put the 1 in, 1 minus 4 is negative 3. 2 times 1 is 2, plus 7 is 9, but the square root of 9 is only the positive 3 for these particular problems when we're solving these. So this one does not work, and x equals 9 is my only solution. Okay, pause this here, turn to your side partner, and talk to them about what you've learned so far. Okay, we have one last type of problem to do, and it's a little different because this involves an inequality sign, not just an equal sign. So we need to think about this just a little bit. It's going to work very similarly. So again, we're going to get our radical by itself. It's got a 3 in front, so I want to divide both sides by 3. The 3's are going to cancel over here, and I get that the square root of x minus 1 is less than or equal to 4, because 12 divided by 3 is 4. Same principle as before. How do I undo taking the square root? I'm going to square both sides. So if I square the x minus 1, the square root of x minus 1, I have to square the 4. When I square root this, I get x minus 1. When I square this is less than or equal to, when I take 4 and square it, I get 16. Now I'm going to add 1 to both sides, and I get x is less than or equal to 17. But here we need to think back to what we did on Tuesday when we looked at the graphs. Think of a number less than 17. Check, will that number work in here? Well, if I pick a number like 5, sure, I can do that. How about if I pick a number less than 0 there, though? Let's say a negative 1, okay? Well, x minus 1, so negative 1 minus 1 would give me a negative under the radical. I can't do that. So not only do we need to think about this, but we also need to think about the conditions under the radical. Okay, so take a minute and put this in your notes. When you're solving a radical inequality, and that's the special word there, inequality, not an equal sign, but a less than or greater than, or less than or equal to, or greater than or equal to, make sure you don't choose values of x that would make a negative under the radical. So in other words, what I want to do is I want to think about the other condition. X minus 1 cannot be less than 0. So x minus 1 has to be greater than or equal to 0. It's just like what we did when we were looking at the graph yesterday or Tuesday. What is the smallest possible value that x can be? Well, if I add 1 to both sides, I get that x has to be greater than or equal to 1, which is what you said yesterday. That's where the domain starts. So x is less than or equal to 17 and x is greater than or equal to 1. I can combine those into one inequality. X is less than or equal to 17 and x is greater than or equal to 1. If all you come up with is these two, I'm okay with that. You don't have to put them together. But if all you come up with is this one, that's not okay. You do have to make sure that the values here will not make what's under the radical negative. Let's look at a couple more problems. Okay, let's look at this one. We're going to try this one together. Now, I have to get this radical by itself. Well, what do I see here? I've got this minus 3. I'm going to move that first of all by adding 3 to both sides. When I do that, I get 2 times the square root of x is greater than or equal to 3 plus 3 is 6. Then I'm going to divide both sides by 2. 2's are going to cancel here, and I get the square root of x is greater than or equal to 3. Now, how am I going to undo this square root? I'm going to square both sides. How am I going to undo the squaring, or if I square this side, I have to square this side. So x has to be greater than or equal to 9. What's the smallest value of x this could take on? The smallest value would be 0. Okay, but x has to be greater than or equal to 0. But let's think about that. We've already said x has to be greater than or equal to 9. If it's greater than or equal to 9, is it already greater than or equal to 0? Yes, so this is the only condition that we need to worry about. Generally, if it's greater than, we're not going to have to worry about this because this is going to end up being our restriction. but it's always good to check. All right, you try this one. Okay, so we're going to divide both sides by 4 to start with. Then, in order to undo this cube rooting, we're going to cube both sides. So if I cube this side, I have to cube this side. Cubing the cube root gives me x plus 1. Cubing 2 gives me 8. If I subtract 1 from both sides, I get x is less than 7. But now let's go back and look at the original problem. If this was a square root, we wouldn't want this to be negative. But can we take the cube root of a negative number? Yes, remember we can. The cube root of a negative number can be negative. We can take the cube root of a negative number. So is there any restriction on this? No. So the only restriction is that x has to be less than 7. All right. So here's your homework. It looks like a lot of problems, but it really isn't. I think they'll go fairly quickly for you, and we'll talk about this on Friday.